So today we're going to learn two more shortcuts for proving triangles congruent: angle side angle and angle angle side. Okay, so far we already know side 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 and side angle side. We learned those last week. We'll learn these two today. There's one more after this one. It's a special case where, remember we talked earlier today about side side angle and how it doesn't work. If the angle is a right angle, it does work. And I'll show you why later this week. Okay? So, here, for angle side angle congruence postulate, if two angles and the included side, yes?
Is there an angle?
It's a great question. Hang on to it for a minute though, please, okay? But it is a good question. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Again, notice that you have to have two angles and the side that's in between them. So it has to be the same for both. If you have two angles and the side in between them on one and two angles and the side not in between them on the other, it doesn't work. It's got to be the same for both. So this is an example of angle side angle to prove these two triangles congruent. Okay, the next one is a theorem. Oops. And it is the angle side angle congruence theorem. It says that if two angles and a non-included side of one triangle are congruent to two angles and the non-included side in another triangle, then the triangles are congruent. Do you see why this is called angle, hang on just a second, angle angle side instead of angle side angle?
Yes.
Yeah, because the side's not in between the two angles. Yes?
What's the difference again between a theorem and a postulate?
A postulate is something that we assume is true because it always seems to work, but we can't really prove it. A theorem is something we can prove is true based on prior postulates and theorems and definitions and the like. So the reason this one's a theorem is that I can prove that this is true based on angle side angle.
But if angle side angle is a postulate and we don't know it works all the time, how can we make something else?
So you have to have, in any system of logical thought, you have to have some sort of basic, we're going to agree that this is true, and we build up from there. Okay?
That would really stink if it's false.
Yes, and that's the problem. It's called a postulate or an axiomatic system. If your initial postulates or axioms, or if any of them are wrong, the whole system collapses.
Like a building.
Yes. You can think of the postulates and axioms as being the foundation that you build upon. Okay? And you can get into all sorts of philosophical discussions about that. You know, what if you believe that people are basically good? Well, then you make certain assumptions about that. What if you think people are basically bad? Then you make a different set of assumptions. Okay? Yes?
Do the angles and sides for both triangles need to be like the same ones?
What do you mean the same ones?
The angles both have to be for this specific thing, or it's kind of easy to explain on like angle side angle, but like for the angle side angle one and for this one, if the angle side angle would have been like N was an angle, and P was the side and P was the angle, but then it was this, but it was the S was the angle. S
Oh, yeah.
is not.
Well, if it was like that, the triangles wouldn't look like this.
So like.
So if I understand you correctly, what you're saying is, what if instead of this and this, if it had been this and this?
Yeah, like it wouldn't be.
It would still be angle side angle. It's just your triangles are really badly drawn.
Oh.
Okay. So back to Sammy's question about, why is this one a theorem? Well, remember, one of the theorems that we talked about is the third angle theorem that says if you have a triangle that has two angles congruent to two angles in a triangle, then the third pair of angles has to be congruent, right? Well, if this is true, then by the third angle theorem, these two, don't write this down, these two angles have to be congruent, right? And then these triangles are congruent by angle side angle. Yes?
When we're doing a proof, and we can, like, I don't know if infer is the right word, but almost infer that the last angle left from both of the triangles is going to be congruent. Can we end our proof with saying third angle theorem, or would you want us to say angle side angle, or angle side theorem?
So the third angle theorem proves that angles are congruent. Angle side angle or angle side proves triangles congruent. Okay? So we really don't ever have to, the reason for having this theorem is so that we don't have to use the third angle theorem and then use angle side angle. Some older textbooks, much older ones, made people, there was no angle side. What they did is if they got one that was going to be angle side, they made them use the third angle theorem to prove the last pair of angles are congruent and then use angle side angle. It just makes your proof an extra step longer.
So this is a recent theorem.
Well, I don't know. It just wasn't, not all textbooks agreed that it should be used. I mean, it's true, but they're like, oh, that makes those too easy. And I'm like, it makes it a step shorter. Whee! Okay. All right. So let's look at some examples. And this is Savannah's question from earlier today. There are two combinations that we will not use because they don't work. Okay? Angle. Why doesn't that work? Why aren't these two triangles necessarily congruent? Yeah, they're not the same size.
They're similar.
They're similar. They're the same shape, but they're not the same size.
Will we ever have to prove triangles similar?
Yes. Next semester.
Fine.
Okay? We will also not use side angle, which was Sammy's question from earlier. You guys asked terrific questions. With side angle, I could have a triangle that looks like this, and see how I could kind of take this side and flip it out this direction and not change the angle or this side, but now I have a completely different looking triangle. This is why side angle cannot be used to prove triangles congruent.
Wait, what?
So imagine starting with these three, with this and this angle and this side. But instead of having this side go this way, have it go out this way. Do you see how that creates this triangle?
Yeah.
And those two triangles aren't at all alike, are they? So that's why side angle cannot be used to prove triangles congruent, because sometimes the triangles will be the same, and sometimes they won't, and you really have no idea whether it will be or not. Yes?
So what would you put instead of side angle?
You need more information.
Okay, so you'd put like, need more information.
If I give you one that's side angle and I ask you which method can be used to prove the triangles congruent, you would put none.
Okay.
Unless you can find more information. Okay? All right. So let's do a proof. I even wrote flowchart on that one.
Ew. No.
Yay!
So I'm going to do a flowchart for this one. So let's see. Angle R is congruent to angle S. That's given. Some years I don't do flowcharts until I get to this point, apparently. That's why I wrote flowchart on there.
Those lucky people.
Angle R is congruent to angle S. And then I've got that
Does that mean that
O is the midpoint of segment RS. That's given. And what can I conclude from this one. Since this doesn't have anything congruent, you're like, I got to be able to conclude something's congruent. Yes, ma'am.
S, O, and all R.
Yes.
I also have another question.
Yes, ma'am.
Because angle R and angle S are congruent, does that mean that segment FR and segment ST are parallel?
Yes. Yes, we could make that conclusion. And so there's a very different way that you could do this proof also. I'm not going to do it that way, but yeah, you could do it.
Is that the converse of alternate interior angles theorem?
Yes, it is. Oops, that's not given. How do I know these two segments are congruent?
Definition of
Definition of a midpoint?
Yeah, definition of a midpoint. And you guys are right. I could, at this point, say that FR and ST are parallel by the converse of the alternate interior angles theorem. And then I could prove that angle F is congruent to angle T because of the alternate interior angles theorem. But there's a faster way. Yeah.
Vertical angles, what's the angle? Shoot. Like FOR and then SOT.
So angle FOR, what about them?
They are congruent because vertical angles are congruent.
Yes.
I have a question.
I have an answer.
Why wouldn't you put definition of vertical angles?
That's a good question. The definition of vertical angles says that vertical angles are two non-adjacent angles formed by two intersecting lines.
So it never tells us about that.
Oh, so then, yeah.
It doesn't tell you that they're congruent, does it? It just tells you what they look like. Yes,
How do you remember all of these?
because I'm really smart.
That's
Like,
bad.
were you really good at like spelling? Like, could you like look at stuff and remember it, or are you just like have been teaching math that long?
Little column A, little column B.
I was like, what is column A?
The first thing you said, and column B was the second thing you said.
Column A.
I was like,
English is the top of our grade.
Yeah, I will say that when I took geometry, back while the Earth was still cooling, that as soon as I saw it, I understood it.
Can't relate.
that's crazy.
Can't relate.
Honestly.
Yeah, it's okay. You don't have to be like that.
I don't get the stuff from the beginning of the year still, but I understand this.
Okay. So do we have enough now to prove that these two triangles are congruent?
Yes.
Yes. And so we will.
Yeah, we will.
So triangle FRO is congruent to triangle TSO by angle side angle.
You didn't spell even the
Yes, I did. It spells frost.
Oh my gosh.
What? That's crazy, Mr. Davis.
I was thinking Christmassy thoughts.
When do you make
We've been thinking too.
Wait. I had too many things at once. What?
Musical has very long.
Yes.
When's Thanksgiving break?
So we.
So we go this week,
Yeah.
next week, then you have Thanksgiving break.
Yes. It's so crazy how close
Our
it is.
last day of school.
I'm sorry?
It's crazy how close it is. It's crazy how close it is.
It's crazy how close it is. Sorry, I couldn't. I was trying to make how close it is all into one word, and I'm like, oh, I can't do this. Yes.
That column A was. What's that song from? It's like, we need a little Christmas. What's that?
Right this very minute.
Candles
It's in the window. Carols in the spinet.
Wait, what's that from?
It's a song called "We Need a
Oh,
Little
it's just a
Christmas."
song.
You're a really good singer.
Thank you.
Didn't you do like play? Did
Oh,
you
yeah.
do theater in college
No,
Or in high school?
in high school.
See, I knew that guy.
Wait, I wasn't looking while I was playing. Did you like the crowd roared as soon as like you were done singing? Did you do some dance or something?
Oh yeah.
Like after
Which night did you go?
all three, I was in the pit.
Oh, because your back was to us, right?
Yeah.
Yeah, I dance with an audience member every night.
Oh, okay.
You
That's
just
cool.
picked an audience.
Wait,
You
did
did?
you not watch?
Did you dance with this
conducting?
Lincoln
They
the
sang.
third night?
Yes, I
No,
did.
That's what I thought.
Yeah, yesterday afternoon I danced with Mrs. Lincoln.
But it was after that.
Who was
part.
that? Who
And
did
like
you
the
dance
second
with
night,
the
it was like this old lady who didn't want to dance.
It was Claire's grandmother.
Oh.
I was afraid she didn't want to at first, and then I was like, oh, come on, and Claire's mom was like, yeah, go, and so we just kind of stood there and swayed back and forth. We didn't do any real dancing.
You
So,
should have danced with Jackson.
Give me Dappy.
all right, so let's take a look at this one. Since so many of you prefer to do 2-column proofs, we'll do a 2-column.
It says fact and
So
fat
wait, it's
and
just
cat.
Sammy and Mary.
Yes, it does.
I'm so scared.
Jake likes them too.
That's fact.
I.
Old Jake. Yeah, Jake.
No,
Yeah,
it's
they
not.
are.
They're way better. They're so
They're
easier.
so much neater.
No, they're not. Yeah.
All right,
Jake.
so again,
I love like you.
opinion questions.
I like arguing too.
So we've got AF perpendicular to FT. We've got AC perpendicular to CT. We've got the segment AC bisects angle CAF. All of that is given information. Notice nothing is given as congruent.
But we can infer that since AF is perpendicular to FT, that it's a 90-degree angle.
Well, not quite, almost. What is the definition of perpendicular lines? It doesn't say 90-degree angle. It says something that's equivalent to that.
It evenly.
No. You're trying to make this. What's a 90-degree angle is called a.
Right angle.
There we go. So we know
If,
that angle F is a right angle.
and can we also infer C is a right angle as well? And therefore-
Absolutely. Hang on. One step at a time.
Sorry.
So angle F and angle C are right angles. How do we know that? Definition of what? Of perpendicular lines. Thank you, sir. All right, Marion, go on.
Can't we then? Well, we know that they're congruent now. Because
Okay.
All right angles are. Wait, we wrote it down earlier. No, it was on our something else on our homework.
All right angles are what?
Congruent.
Are congruent. So now we've got one pair of congruent angles. Is that enough to prove the triangle's congruent?
No.
No. Now, here we have AC bisects angle CAF. We should be able to make a conclusion from that.
You can say that angle FAT is congruent to angle CAT.
Perfect. Angle FAT is congruent to angle CAT. How do you know that?
Definition of angle bisector.
Very good. Definition of angle bisector. Please be sure that you're not just putting definition of bisector because there's also a segment bisector. We have to differentiate between the two. Yes, sir.
Wait, did you say AC bisects CAF? Would it be AT?
Oh, this should say AT. You're exactly right. Thank you.
I'm really confused.
Yeah.
Sorry about that. I didn't even notice it.
Could you not say?
Oh,
Could you not say that AF is congruent to AC? That's what
how would you know that? Because an angle bisector takes an angle and cuts it into two congruent angles. It doesn't make congruent segments. So since we're bisecting this angle,
But if it was A bisects AC, it would be.
no, a point can't bisect an angle.
So you can't say FA?
No,
I've always done that. Could you?
if we had a midpoint, so if F, A, and C were all on the same segment, and A was the midpoint, then we could say that FA and CA were congruent to each other.
Well, if we don't know, we can just say like the third angle theorem.
We could, but we don't need it.
Okay.
Because does angle, angle, angle prove the triangle's congruent?
Nope.
No. So there's really no reason to do the third pair of angles. But, yes?
AT is congruent to AT because of the reflexive property.
Indeed. Is that enough to prove the two triangles congruent now?
Yeah.
By?
Side, angle,
Angle, angle, side. If you put side angle, angle, I probably wouldn't count off. Probably.
Probably. So if you were having a bad day, you might probably not.
Yeah, it's all about my moods. I'm terribly mercurial.
What does mercurial mean?
Changeable.
It sounds like mercury.
I'm basically a different person every single day. You never know what you're going to get.
Isn't that like how you're bipolar?
I know, I was just gonna say that. That just means you're bipolar.
Are you bipolar?
Sure. So the word mercurial comes from mercury,
I know. I said it sounded like mercury.
which is sometimes called quicksilver.
Isn't it really dangerous stuff? It's very poisonous.
Yeah, it's not good for you.
Don't eat off of plates, maybe.
Don't eat off a plate.